Okay, in this video we're going to talk about the analysis of variance for a mixed factorial. We're using the same example we used for the factorial, that is alcohol and exposure duration, but now alcohol is between subjects, but exposure duration is within subjects because we decided it's simple enough to show people some words very quickly and others very long, and we can test that within subjects. So it's a mixed design. Same data that we had in the factorial, right? And what we have now is something that's a little different in our source table for our analysis of variance. Let's first focus on the things that are the same. We have a source of variance which is due to our factor 1 or factor A, which is alcohol, right? And then we have the same thing for factor B, which is exposure duration. We have an error term here, right? That's all the same. But we got some stuff that's a little, and we have total, that's also the same. But the things that's a little bit different is we have another error term, right? That's unusual, and we have this A by B thing, okay? That's the same. That's our interaction term that we also had before. So one thing that sticks out to you is when you have a mixed design, you have two error terms. And the reason you have two error terms is this factor is between subjects. So the error term, the residual, includes subject effects. So when we calculate this mean square, we divide by this other mean square that has error variance, subject variability, because it's between subjects. We're then going to get an F. But for the other one, we did have a repeated measures variable, right? A within subjects variable. So that means that we can remove subject variability, and it is taken out and hidden from us. And so this error term, which is smaller, is going to be used for our repeated measures IV, or in this case, exposure duration. The cool thing is that the interaction can also make use of the smaller error term, boosting the power, smaller error term here for the interaction as well. So we still end up with our 3 F's, but they have different error terms. So let's look at the output here. For alcohol, you'll see that here's the mean square, and then there's the error, right? And that F, of course, is significant, so alcohol had a significant effect. But let's look at exposure. Here's the mean square for exposure. Here's the error term. It's very small, and the reason it's much smaller is because subject variability is calculated and removed from this particular analysis. And so the 408.48 divided by 0.14 is this F. That's significant. And this 23.58 is divided by 0.14 as well. It gets to use the smaller error term, the one that has subject variability removed, and it too is significant as well, less than 0.001. So all 3 effects, the 2 main effects and the interaction, are significant. So the biggest difference here is with a mixed design, you have 2 error terms, one that includes subject variability and one that does not. The term that does not include subject variability goes with the repeated measures IV as well as the interaction.